everyone. My name is Rachit Arora, and I am going to take you through this session where we will discuss when and why build operators. Before we begin, very quick introduction. I'm a software architect at IBM India Software Labs. I come from a team where we provide three services on IBM Cloud. First one being IBM Analytics Engine, where we offer a managed cluster service as a service, where we are giving Hadoop and Spark as a cluster. We offer Hortonworks Data Platform as a full stack cluster for our consumers. And the second service which you have on IBM Cloud is called as IBM Watson Studio Spark environments, which is a serverless experience of using Spark on cloud, where data scientists, data engineers, basically anyone looking for a Spark runtime can come to Watson Studio or data analytics platform and request for a Spark Jupyter notebook. And the runtime comes in few seconds. This runtime is running on Kubernetes. So we have a large number of Kubernetes clusters, each having a large number of worker nodes, and Spark runtimes come and spawn in few seconds. Uh, in our public cloud offering, we have created more than 2.5 million Spark runtimes using on Kubernetes. So we are primarily having expertise in deep expertise in Kubernetes and managing Docker containers at large scale as well as big data. Um, I'm also authoring a book on algorithms in big data, which will be released shortly. And I also term myself as a conference traveler. Before this pandemic, I used to travel to different conferences, talk about these latest technologies, how do we do these, manage these large scale deployments, and take some feedback and share our experience of running such service. Okay, so just to set some background on how the distributed runtimes have evolved over time. There used to be a time where people used to run entire analytics on-prem, where they used to first acquire the right set of hardware for running their analytical workloads or running any distributed application. And then they need to prepare that hardware. By preparation of that hardware, what I mean, they need to set up the disk, they need to set up different types of network, and they need to partition the disk, install the operating system, install the required prereqs for installing the software like Apache Spark or Hadoop, and try to install this distributed analytical application like Apache Spark. And most of the time, this installation used to fail, and and they need to retry fixing the problem. The problem could be some missing dependency or some problem with the disk, so they need to fix it and retry it. After multiple attempts, which could go from days to weeks, they used to get a successful installation of a runtime, but they still need to manage at runtime by applying various security fixes, by upgrading the operating systems, applying this patches for the CVEs which are being opened. They need to manage the scale of that runtime depending upon increasing and decreasing workload in their organization. They need to manage the high availability of the runtime. So they need to do a lot, right? With the increasing demand for the analytical runtimes in their organization, they could opt for virtualization technologies. Like they will have some VM images created, which will help them solve most of the installation related problems, but they still need to manage network, high availability, they need to apply security patches and manage the scale. So in order to meet this increasing demands of analytical workload, they use think about public cloud offerings. There are public cloud offerings like Amazon EMR, Microsoft HT Insights, IBM Analytics Engine, Google Data Proc, which offer them managed cluster as a service, which they get a Spark runtime in few minutes. But those clusters were built very generically, so they had to customize and configure the runtimes for their needs. And the biggest problem with that approach was that if they are not using that runtime fully, and they're not running Spark applications all the time, and that runtime is lying idle, they are paying for the compute resources even if they are not using it, right? So what customers are really looking for was running analytical workloads in a serverless fashion, which they could achieve by running on Kubernetes and evolving it to further to running on a K-native or pure serverless fashion. So when we need such a service, there are expectations from the customers that there should not be any downtime. There should be 99.9999 availability. There should not absolutely not be no support tickets. We should be able to deliver new features like latest versions of Spark, latest version of Conda packages very fast. You need to have the best of the security available. There should be absolutely no security risk while running on public cloud. We should be able to manage the huge scale, like there will be a sudden shoot ups of the demand, and there will be demand will be low at some time. So that you need to manage your compute sources accordingly so that you can offer the service in a cost effective manner. So if you need to successfully run such a service, what are the things you need to take care or meet all the expectations? You need to think cloud native. Uh, you need to build a system which is self-recoverable. You are able to deploy your new changes seamlessly and have a very strong CI/CD pipeline which is able to catch any regression early in the cycles before hitting production. You should be able to deploy in few hours once your code is merged and basically with any manual intervention. So that is something very key things you need to keep in mind for offering such a service. So here are some of the key technologies which can help, which we are using to offer services on cloud, which is really helping, which range from Jenkins for CI/CD pipeline, running everything as containers on Kubernetes, using Helm charts to have a template for most of your runtimes, using Istio for doing A/B testing for other mesh related work, and adopting operators for removing any manual intervention which we have. So let's see some trends, how the container technology and Kubernetes is evolving. So as per the CNCF survey of 2019, the adoption of containers since 2016 has increased a lot, especially in production. There are more and more people using containers in production as compared to the previous years. And the number of containers being used in production is also increasing a lot, right? So more and more people are using containers for not only their dev, but also in their production. But the key challenges which people are still facing are around that they need this container-based workload to basically they are not able to scale it as per their workload. They are having problems to monitor and logging and service mesh related problems. They are not able to run in a serverless fashion, and they don't want to use the technologies which will force them to be on a technology lockdown, right? As per the survey, the key pain points which people are still facing for using Kubernetes is around the admin or the operator or the developer experience, where um, there are a lot more challenges to be solved, right? So can we address these problems using operators? The answer could be yes. There are some scenarios where operators can help resolve some of those issues, and in some scenarios, operators may not be the right fit, right? Uh, so you will, as part of this conference, you will learn about more about what is the operator framework in some upcoming sessions, how to build them. But what this talk is going to focus is primarily on the scenarios where you can use or build operators and where they can really help you solving some of the challenges which you might be facing in your organization. So let's see one of the first scenarios where operators can really help, right? Let's say you want to run a custom application on Kubernetes, and that custom application happens to look like very similar to what um, Apache Spark offers. In typical Apache Spark, it is a uh, distributed analytical compute engine for running your analytical applications. And there is a Spark master component, and there are Spark worker components, and there could be multiple workers, and all workers interact with master, and the work is done in a distributed fashion on worker, right? So if you need to deploy such an application, there will be multiple pods involved. There will be a Spark master pod, and then there will be Spark worker pods, each having some configurations and secrets, some volumes to be mounted. And if you need to deploy them on runtime, what you can do is you'll have a bunch of microservices which will be managing your input requests, which again will be deployed on Kubernetes cluster. We can term it as control plane, and here your actual uh, um, runtimes are deployed. They can be deployed on a same Kubernetes cluster or on different Kubernetes cluster, which we can term it as a data plane, right? So to request to deploy such a custom application will come to your ingress of your control plane, where it will be handled by different set of microservices like access controller, check the input validation through your job, and get it deployed through a microservice, something called as a deployer, who will be responsible for getting it deployed in one of the data planes. And again, on the data plane, your request will be received by ingress controller, followed by a gateway to route it properly, and then these components will be deployed. So, so if you need to build uh, such or build and deploy such a custom application, and if you need to do everything on your hand, you will be um, going with this microservices kind of architecture. Whereas you can have this entire microservices architecture orchestrated or built using operator, which would be something like a Spark operator, which will be responsible for doing all jobs which your microservices will be doing, will be managed by that operator, and you'll have a seamless deployment. The second place where you can think of deploying operator is to when you need to set up or use a service mesh. So if you have a Kubernetes cluster and you need to deploy Istio on top of it so that you can do service to service communication. You can have your SSL termination done by Istio, have your authentication authorization handled by Istio. You are able to do A/B testing and you are able to apply rate limits and quotas for your incoming requests. But it could be really sometimes hard to install Istio on your Kubernetes cluster. So there are operators available which can help you deploy Istio on your Kubernetes cluster so that you can use them for solving these use cases. Another key area where operators can really help you is when you need to use some key value store like etcd or Zookeeper. You can use operators to deploy these application like etcd operator or Zookeeper operator so that you can easily install and manage this key value store, right? So operators are already available, which you can use to install etcd and Zookeeper for installing them. Another key area where operators can really help is to manage compliance, right? So for any production grade service, you need to have automated uh, way to check whether all the images which you have deployed on production, is there any new open CVs which are impacting your images? You need to check all your Git repos, do the source scans so that all the code which you are deploying is good. You need to also do OSS scans so that to find out if what all open source technologies you are using. You need to keep checking your Kubernetes worker nodes that if there is any new security patch which is being released by your Kubernetes provider, or if you're working on on-prem, if there's some new vulnerability which is impacting your Kubernetes worker nodes, right? So either you will have some Jenkins jobs or some automation which you would have built or you are doing it manually, these operations. You can think of building operators to continuously checking whether is there any image which is vulnerable or having any CVs, or you can have operators to do your source scans or OSS scans. You can have also operators to monitor your worker nodes for if there is any security patch required on them. You can also use operators to manage the health of your Kubernetes cluster. Uh, like there will be scenarios when some new pod is created, the creation of that pod may be failing for some intermittent mount issue or some sandbox errors, which could be coming because of some network issue for that container, or your image, if it is a huge image, it is not pre-polled on that worker node. And the pod may be failing because of that, or it may be in the pending state for a long time. So you can have operators to basically identify the Kubernetes worker nodes which is having any of these issues. And you can also have operators which can monitor the disk issues or the network issues for your Kubernetes worker nodes. Another key area where operators have really helped is to, in order to have, if you need to install a multi-component uh, application on Kubernetes, you can plan to have an operator which has capabilities of installing different components, and it has capabilities of reinstall, uninstall, quies or upgrade, or even backup and recover your component, right? So if you have designed your application which is multi-component application. You can have install operator, which offer all these capabilities, and your components can be installed using an operator. So the operator will be managing the life cycle of that component, and it can give you status, it can give you install, uninstall, quiz, and upgrade, and other capabilities. So you can also think of using operators for managing the Kubernetes worker nodes from the monitoring perspective, also from um, creating the new Kubernetes cluster or altering a new Kubernetes cluster, or even adding new worker nodes, or even doing some admin operations of installing new patches, which will be doing something like cordoning the host, draining the host, reload them, wait for them to be ready, validate whether they are ready for production, and add it back to the production, right? And you can have operators to have your images pre-pulled so that your worker nodes are ready for production. You can also think of having operators for your deployment pipelines, which will basically make sure that uh, uh, basically you should use your Jenkins or Travis as your orchestrators, and each individual task which you may be doing through some shell scripting over a wrapper of a Jenkins job can be done by an operator, so that the deployment task is managed by an operator, and that operator has ability to do periodic checks and some validations at any given time that your production is doing healthy, and that operator can be responsible for doing such jobs. Okay, so over the period of time, from our experience, we have seen that many a times where we are using cron jobs for doing some critical operations like uh, monitoring particular health of a system or pulling Docker images. It's not really a good idea to have cron jobs for all such critical operations, because we have seen that if there is your cron job is failing to be scheduled for X number of times, it will basically come into a phase that it is no more schedulable, and it will stop scheduling them. And basically, you will think that your cron job will come, but it will be halted unless some manual intervention is there. And another area, let's say if you have a small Kubernetes cluster and you have a cron job which keeps check for any dangling pods, which you can use it as a garbage collection or cleanup mechanism. And if you are designed to use cron job for such doing things, it may not be a very good idea, because your if your cluster is full, the pod which cron jobs will come and kick in, it itself may not be able to schedule to do or trigger that cleanup, right? So you can think of using operators to replace cron jobs for doing some of these critical operations, which will be better managed using operators. Another key area, when especially working on public cloud, where you are offering something equivalent to compute as a service, maybe in different forms, you need to keep a check on the crypto mining activities. So you can build uh, operators to monitor the runtimes or your pods which are running on Kubernetes cluster, whether if any such pod is running crypto processes or not. You can also keep a check on why a certain pod is running for a longer time than its scheduled time. You can also prepare a disallow list that these certain processes are not allowed to be run inside the pods. So you can use operators to uh, uh, keep a check on any crypto mining related work which might be happening on your runtimes. You can think of using operators for doing the admin related work, where you need to at a regular interval of time take DB snapshots, say, prepare the snapshot, keep it in a safe place, uh, and keep the check of the last few snapshots, keep archiving your old snapshots, so that entire pipeline of backup and recovery can be automated using operator. You can also use operators for doing complex administrative activities like uh, granting access to your certain part of your runtime, having the validation policies like don't allow privileged pods to be run, don't allow pods to be run as root user, don't allow any admin to do exec inside your pod, do not allow pod to be run using vulnerable images. So to validate or enforce certain policies, you can have operators created for them, right? You can also create operators to manage failures at the runtime so that you can recover, self-recover. Um, for example, you can have operators to keep check if there is any pod which is like a dangling pod and it is not required to be there because its parent application or job has failed, and this should be removed. And there could be scenarios that you have requested for a deletion of a pod, but it is stuck in terminating phase for a long time and you need to do a forceful delete. So you can think of having operators to remove such uh, dangling pod so that compute is available for your other resources. So as I mentioned, in order to truly run serverless workload, you need to start adopting Knative, which is basically a layer on top of your Kubernetes. This is again a new open source project which gives you uh, different types of resources to run your serverless workload. These resources are bracketed under Knative eventing and Knative serving. And if you have use cases where you need to use Knative or install Knative, you can use operator to install it for you rather than having to do or hands-on installation of Knative. So there are other more use cases which I've not tried myself, but you can think of doing or using operators is to manage configuration. Like you will have a different set of configuration for your pre-production environments or your dev environments, and you need to uh, run the same pods in production, but with a different configuration. So you can have operators to switch the configuration or manage the configuration based on the environment where you're working on. And you can also think of using operators to help you build a balance between a multi-cloud or a hybrid cloud kind of a deployment architecture. So to summarize, operators are like controllers, which can help you manage the work which is being done by your DevOps or by human hands, on which you would have been creating an alert for a human to come and take a look. And you can use operators to automate all those scenarios so that you can offer a better service to your consumers. You can think of using operators for replacing your installation or scalability or update related code. And it can be used to manage the lifecycle of distributed or clustered application, something like Spark. So think of operator only as a design pattern um, with which provides reusable templates for doing various tasks and manage your application's lifecycle. So I have a blog on medium.com where you can read more about such scenarios. It's called When and Why Create a Kubernetes Operator. Please do go and read more details there and provide your feedback. If you need to reach out to me, you can reach out to me on LinkedIn. Rachit Wanarora is my handle, and you can even write to me over email on this email ID. So that's all I wanted to cover. Thank you very much. I hope you would have built some more understanding or have some more ideas of building new and using operators for managing your workloads on Kubernetes in a better way. Thank you. Thank you very much.